Hello everyone, welcome to Computer Science E7. This is lecture 9, digital cameras. So starting today, we've been doing a lot of leading up to this point, but starting today we're really going to start getting into the nitty-gritty of digital cameras specifically. So whereas a lot of the techniques and topics that we've talked about up until this point could really be applied to both film photography and digital photography, today we start breaking it down and having an enjoyable time with the digital aspect of digital photography. But of course, I'd really love to tease you guys, and so I'm going to tease you one more time. And before we get into that stuff, talk about assignment 4, raw material, that is just passed out to you just now. So in addition to the, in addition to the usual parts where you have a problem set style part, a collection of photos, and a part where you are discussing your photos online with your fellow students. There's also a fourth part in this one where you're going to be designing a website theme for the course website. And so there's multiple components to this, as you might have noticed in your perusal of the website up until this point. First and most obviously is the photo at the top, the banner photo that exists at the very top of the page. And there's a very specific size and not only size but color requirements that we give to you for processing this image and submitting it. And so you'll notice that if you actually take a look through the problem set, that there's the size is set pretty rigidly at 898 pixels by 250 pixels, rather than a very nice and cozy 900 pixels by 250. And that ended up actually being because of a long-standing website bug where it basically takes off 2 pixels from the sides of the image. And those of you that are familiar with coding websites, and CSS in particular, might know the sort of hassle that I'm talking about. So that's why that particular requirement is sort of strange. Now, in addition to this photo, which, by the way, I certainly recommend you take this photo in RAW and then you process the photo so that you are able to squeeze as much quality out of this photograph that you possibly can. Undoubtedly, you want this photo to be sort of your best image that you have so far, your most representative image of your style, or of your skills even. And so, just because, keep in mind that whereas in the Flickr user or in the Flickr E7 group, where we share all of these photos with each other, we don't really share these photos with the outside world. And we do actually have people from all over the world coming to visit this page. So this is much more of a public way of showing your photos to the world. Now, in addition to that, the photos also come with a color theme. And you'll notice that every theme that is on E7 has a different color theme. And so, oh, I should have loaded this beforehand. Now, in this theme, for example, in all of the themes, what they try to accomplish is to get the overall color theme from that particular photo and replicate it in the website itself, so that when you visit the site, then it's the same photo, so that it has a sort of contiguous feel. So you might have, if you have very primarily green photo, for example, you might have a theme that includes a lot of green. Now, specifically, there are 4 colors that are involved with this particular theme. There's a background color, where for the background of the page as a whole, a content background color, then a text color, which in most of these themes is black. So usually the content color will be a light color, like a cream or a very near white or a very light green, as in this case. And then finally a highlight color, which is used for the link text and also the lines that are drawn around the content type, or around the content of the page itself. Now, in each of these, so what you'll do is you will select a color theme for these 4 colors: the page color, the content color, the highlight color, and the text color. You will format the color in a particular way in this format called hexadecimal. So those of you that are familiar with web programming might already be familiar with this, but if you're not, don't worry too much. We've already dealt with this sort of thing in a different way. So if you remember from a few lectures back, when we talked about 24-bit color, or specifically JPEG file format, we said that we had 8 bits of color information for each of the primary colors in terms of computers. So red, green, and blue. And each one had 8 different bits of information. And that sort of thing is replicated here. You see we have 6 total digits. So that means that we have 3 pairs of information. And that is exactly what this is. So the first 2 represent red, the next 2 represent green, and the final 2 represent blue. Now what makes it hexadecimal versus normal decimal, a normal number that you and I would be able to understand, is that it goes not only from 0 through 9, as we know, but it also includes A, B, C, D, E, and F. So which means that rather than each digit having a total of 10 numbers possible, each digit has 16 numbers possible. So that means that if we have 2 digits at 16, that each of these pairs can represent 256 distinct colors. So basically we're cramming all of this 24-bit information into a very shortened representation of one particular color. Now I did go over that pretty quickly, and don't worry about it. There's a lot there's a link on the problem set itself, and also a lot of information online about hexadecimal colors if you're confused or if you have any questions. And of course, you certainly can feel free to send an email to us, and we'll be able to help you out with that. In addition to all of this, you might be wondering how you can actually pick a color or a theme of colors that would actually work for you. And so we do actually include a number of websites as well that I'll just show a couple here, where you can generally, what's its colors? I know that this worked because I tried them all before I had these printed. And what you generally can do with these is you upload an image, or you send these websites to a URL location of an image, and it helps you out. It shows you some of the major colors that are associated with that image, and then your job is to try to figure out which ones you like best and which ones are going to look the best with your photo and be legible and be well represented on the website. And in fact, we do provide one neat little tool where you can enter in the 4 hexadecimal numbers and click a button that says try this theme, and then it will show you how that theme looks on the website. And there is something very important to note, and that is that the top image won't actually change. So what you might have to do is, after you try the theme, you might bring up your photo in Photoshop, for example, and just hover the window over the website so you can try to get a feel of how it looks. But just to give you an idea, I can try to enter in a theme right now and just show you what this might look like. So a page background, I might use all Fs, for example, which will represent the color white. Content, maybe I'll do something a little bit less than white, like a sort of gray. Highlight, well, let's do something sort of crazy and do all red. And text, we'll just do a very simple black. Now when I click try this theme, you'll see that it changes the colors to represent what your theme might look like. And in this case, this is a reasonable theme because everything is legible. It's not really contrasting. It's not really harsh on the eyes or anything like that. And that is what's one of the most important things about this theme is that not only do you submit a very good photo that is pleasing to the eye, but also you're able to use the representative colors from that photo to make an aesthetically pleasing and legible theme for this particular website. And so that, I think, will be a pretty fun way of getting one of your photos up and published on the internet. And of course, I did pass out the final project specifications 2 weeks ago. And just to give you a quick reminder, you might want to come up with several different ideas, or you might just want to come up with an idea that's representative of what you are interested in getting out of this particular class. And so it's not limited to just submitting regular photos. You can submit, for example, like a magazine cover, if that sort of thing is what interests you. However, just one image may not be enough. You may have to submit several of them. You could submit, for example, a movie, a compilation of images into a movie, such as a stop motion animation or something similar to that. Even anything that you can imagine in terms of brochures or presentations, anything like that is certainly fine. The format doesn't really matter all that much in terms of the end format. You will have to submit the actual JPEG files, the images themselves that make up that format, but in the end, none of that, the end format shouldn't really matter. So whether you do this in electronically in an electronic form, such as a movie, or in print form, that's certainly fine. Just remember that you will have to submit those photos electronically as well. Okay, so without further ado, I figure that we will go into talking about digital cameras, and I just want to fix my screen here so that, all right. We will start talking about digital cameras, but remember that a few weeks ago we started talking about the dynamic range of a digital camera. And what is the dynamic range? What does that mean? Right, exactly. So it's the range from light to dark of what the camera is capable of capturing on the sensor. And in this photo example of what is, again, an embarrassing photo that I, for some reason, show far too often in this class, is the dynamic range of a scene that is too wide. There's too much dynamic range for the dynamic range capable by the sensor itself. So in other words, there's some dark shadow regions that are too dark for the sensor to be able to capture detail. And at the opposite end, there are some light highlight regions that are too bright for the camera to be able to capture detail. And I talked just very briefly about different sorts of dynamic ranges that you can expect from different cameras. Generally, from larger cameras, such as those from digital SLRs, you can get quite a few more stops of dynamic range out of a scene than you can from a smaller camera. And this may make sense because, in the sense that, well, digital SLRs, they're bigger, they're heavier, they're more expensive, so they should perform better. But there's actually a very good reason for this to happen as well. So if you remember, when I started talking about dynamic range in a more quantitative, in a more concrete way, I said that we could use this analogy of a bucket that's collecting rainwater, and we're trying to measure the amount of water that has fallen into this bucket. So the analogy, of course, is talking about a pixel being a bucket, but light is coming down and filling this bucket as rain comes down and fills this particular bucket. So in terms of this, how do we define the dynamic range? So the definition that we had in the last slide is correct. It's just not a quantitative way of describing the dynamic range. How can we quantitatively describe the dynamic range of this particular pixel or this particular bucket? So we're talking about the range from the maximum amount to the minimum amount. So you might be able to say, okay, well, there's definitely a maximum amount of water that I can fill in this bucket before it gets too full, spills over, then I won't be able to capture any more information. I know it's full, but other than that, I don't know how full or how much overfull it is, if that makes sense. But then there's also a minimum where I can say, okay, it rained just a little bit, but I can't put a measuring cup down there to really measure it because it's just not going to work very well. I see that there's a little bit in there, but it's just too little. So we can define this as being the maximum amount of photons, or the maximum amount of water in the bucket, divided by the minimum. And it's as simple as that. So however many photons or droplets of water we're able to capture into this bucket, divided by the minimum amount, or the smallest amount that we are able to capture or able to read, actually, in this particular pixel or this bucket, is the dynamic range of this particular sensor. And so keep in mind that when we're talking about this analogy, we're talking about 1 pixel in the millions of pixels that exist on a sensor. So to scale this out, you would have to imagine a huge array of buckets, 3,000 buckets wide by 2,000 buckets deep or something like that, and you have then 6 million buckets that are all arranged in this very large area. But this is sort of the same thing that we're talking about. We have this very large array of pixels. And different amounts of light are falling onto different sections when we're measuring how much has fallen onto each of these buckets. Now, in order for us to talk about this in a more concrete way, in terms of how this, to remove the analogy from this and talk about how this impacts us in a greater sense to digital cameras, we need to take yet another step back and talk about sensors themselves. So talk about the big picture of sensors themselves. And so realize that, and this is probably obvious, but I should mention it anyway, that different cameras can have different sized sensors within them. So the sensors, for example, in your compact camera or in your camera phone are considerably smaller than the sensors that you can find in a digital camera, or rather in a digital SLR, for example, which are generally much larger than those sensors found in digital cameras. Now, they come in all sorts of measurements. You will generally hear, for example, the full frame digital SLR, sort of the goal or the marker for all digital photographers to try to achieve in terms of their equipment is the full frame 35 millimeter sensor. Now, as you start going down the line in terms of size, you will see compact cameras have different sizes of sensors as well, and they're named things like 1 divided by 2.7 inches, 1 divided by 1.8 inches, 2/3 of an inch. And even though those sound very confusing, I have to tell you that it's even more so, because that actually doesn't have that much to do with the size of the sensors themselves. So just to give you an example, if we take this 2/3 inch sensor and we make a circle, we draw a circle with a diameter of 2/3, that's that circle. Then the actual sensor, the actual rectangle that's within there is the actual size of the sensor in the format called 2/3 of an inch. So yeah, I know it's confusing, and generally the way you can think of it is, okay, well, take whatever size this is, it's about 2/3 of that, so about 66% of that size, and that's the diameter, or rather the diagonal of that particular sensor. It's not exact, it's not an exact science, and the reason for this is actually, I think it has to deal with ancient, or not ancient, but decades old TV technology where the sensors dealt with certain size tubes within the cameras themselves, and this circle is the size of the tube, and then the square part is the size of the sensor within it. It's complicated, I don't really understand, and it's a stupid system. They should do away with it, but it's here to stay, as with everything else. So realize that you can at least get a general sense of the relative size of these sensors based on how big they declare themselves to be in terms of the type. You can almost always get the actual sensor size in terms of millimeters from your camera's specification book or from reviews online. It's generally, you don't have to rely on this information as being sort of the end-all be-all of the sensor size. You can actually get the raw sensor size from your camera. And just to give you an idea, let's see, I do have somewhere around here, let's see, different sensor sizes that exist. Okay. And you'll notice that these really vary quite wildly. So here's just an example of some of the sensor sizes that we have. I'm just going to make it a little bit bigger so it's more legible. So we have, starting at sort of the low end, and there's probably smaller than this, we have 1 divided by 3.6 inches, and we get a sensor size that is 4 millimeters wide by 3 millimeters high. So that's really small, very, very tiny. And then at the opposite end, we have 35 millimeter, which has a very, very large size of 36 millimeters wide by 24 inches tall. And so that's quite a big difference in the sensor size between a 35 millimeter full frame camera and a compact camera. And I hate to say it, but in terms of digital photography or photography as a whole, size does matter. So the bigger sensor you have, you are generally going to get more options in terms of the quality that you can get or what you are capable of doing with that particular sensor. So while there is a lot of abstraction in terms of the f-stop and the way that they make all of these numbers similar across each of these different cameras, there is actually a big difference between cameras that have a very small sensor compared to cameras that have much larger sensors. And that is mostly what we are going to be talking about today. Any questions on this stuff? Okay. Now, in addition to these small compact camera sizes, there's also various sizes within digital SLRs as well. So just because it's a digital SLR doesn't mean that you're going to get a full frame 35 millimeter sensor. You might get, depending on the type of camera that it is, you might get something else, something called, like if you're on the Nikon side, Nikon DX, for example. If you're on the Canon side, APS-C, or you might get something else called APS-H, or some of these other various sensor sizes that exist today. And if you're really curious, you can, of course, look up what these sizes mean in real terms on a table such as this. You can literally just Google around for camera sensor sizes, and then you'll be able to find tables like this, not only on dpreview.com, but Wikipedia. They're all over the place. Anyway, the APS-C sensor size is actually smaller as well from the 35 millimeter full frame sensor. So whereas the full frame is 36 millimeters by 24 millimeters, the APS-C is generally around 25 by 16 or something like that. It actually varies from manufacturer to manufacturer how large that particular sensor is. And that is, again, very important to us. Now, one last thing that I want to point out as well is the aspect ratio of these sensors. So these very large sensors here, so the APS-C 35 millimeter and what's called a medium format 645 sized sensor, all have an aspect ratio of 3:2. Well, I guess except this medium format, where it's more square, and it shares the aspect ratio of these smaller sensors from compact cameras of 4:3. And just to give you an idea, if you remember the old school TVs that the very large ones that were sort of square, those were also 4:3 aspect ratio. So it's sort of a square aspect ratio compared to these slightly wider, but not too much wider, digital SLR formats. And so that can be important, and it can be a bit of a shock if you go from a compact camera to a digital SLR and you suddenly realize, well, the frame isn't quite as tall as I thought. It's a little bit wider than I'm used to. That is certainly the reason why. It's this aspect ratio that has changed from one sensor size to another.